Good morning, everyone. Welcome to the recorded version of CS 186 Exam Prep Section 1. First, we're going to have a mini lecture, which will be a highlight reel of the most important and useful concepts from each chapter. Stepping back, the goal of this section is really to give you all practice solving hard problems. And so by the end of this section, you should be able to tackle exam level questions related to SQL, disk files and buffers, and B+ trees. First, we have a mini lecture on SQL. By now, especially after Project 1, you should all be very comfortable with single table SQL. And almost everything you need to know about solving single table SQL will be encapsulated in this slide. So if you know the logical processing order, this is different than the way that we write SQL queries. So if you know the logical processing order, you should be able to solve any single table SQL problem. Okay, so whenever you're given a query problem, the first thing you should ask yourself is, where is the data I want stored? From specifies which table we're drawing from. Secondly, what rows do we care about? Where takes in a Boolean predicate and returns only the rows that meet the predicate condition. So we've filtered out some rows, but are we going to group by any rows? Group by takes in a list of columns and groups rows by the value of those columns. So columns with the same value will be in the same group. Fourth, what groups do we care about? And so having will take in a Boolean predicate and return only the groups that meet the predicate condition. Fifth, what columns do we care about? So finally, this is where select happens. Select will take in a column list and return only the columns in that list. We can also use the distinct keyword to filter out duplicates. Next, we take a look at the resulting table and ask ourselves, is there any order we want our results in? So order by takes in a column list and orders the output by the value in those columns. And you can specify whether to order in ascending mode or descending mode with ASC or DESC. Finally, how many rows do we care about? Limit takes in a number and outputs the number of rows off the top. So if you're ever unsure of whether a query is legal or not, write down the states of the table, changing in this logical processing order. And in the end, you should have a valid SQL query, or you can check whether it is or not. All right, let's move on to multi-table SQL. Really, the new contribution here is that we are joining two tables. And the big idea is that joining tables in SQL comes down to answering what's the type of join that we want to perform and on what join condition. And the result of a join is just a single table. So we can apply properties of single table SQL, which we learned in the last slide, to finish our query. Now, in any join query, you'll have two components. First, we specify the type of join. And then second, we specify the join condition, which specifies which rows we want to keep based on the column values. And under the hood, a join takes the Cartesian product of two tables, which enumerates all possible row combinations between our two tables. But for rows that don't match our join condition, what do we do? The different types of joins determine what we do with joins that don't match our join condition. Let me tell you what I mean. So for an inner join, we simply get rid of all rows that don't match our join condition. For a left join, we keep all rows from our left, fill all right table column values with null. For reverse, all rows from the right table, fill all left table join, we don't get rid of any rows. Instead, we fill in any missing fields. Default uses join. So T1 inner join T2 on some condition is equivalent to from T1 comma T2 where some condition is met. Null is used to fill in the entries with no matching data points. And inner join is the only join that wouldn't have any null values by definition, since the results must match on both sides. And if there is no join condition, so this is the last point, if there's no join condition, just return the Cartesian product. That's what SQL does. Cartesian product is the all possible pairs of rows where each pair has one row from the first set and one row from the second set. Here are a couple points that may not have been emphasized in discussion, but will sometimes occur in exams. The first perspective is on SQL as sets. A union is all items in either set, and an intersection matches items in both sets. The first point is if you want to include duplicates in your answer, you must include the all keyword, like union all, like T1 union all T2, or like have a query where you union all with another query. The union or intersection keywords are typically used between two different queries. For example, we may union two queries with, select blank from table 1, union select blank from table 2. The second point is we have correlated subqueries. Sometimes we want to perform correlated subqueries. A subquery depends on values from the outer query, and the subquery is recalculated for every row of the outer query's table. An aggregation will take a group of values and squash them together in some way. So an example is count, sum, and average. The key thing to remember is the SQL logical processing order that we went over in the first slide. You can't apply aggregations in a where clause because you have to wait until you've grouped the rows in some way. Null columns also will be ignored by aggregate functions. And next, having filters out groups, where filters out rows. So you shouldn't ever have to use having if you don't have a group by. Finally, you can use this thing to remove duplicate rows. Okay, great. Feel free to use the Piazza post for exam prep section 1 to ask questions.